Now we're going to look at another method of solving systems of equations using the inverse of a matrix. So before we get to the solution method, we need to know what an inverse is, and for that we need the identity matrix. So the identity matrix is in the matrix that when you multiply it by another matrix results in unchanging that matrix. So just like 5 times 1 is 5, right? And 1 is our identity in the real number system. The identity matrix does the same thing. It's like multiplying by the number 1. It doesn't change the value. So the identity matrix is a square matrix, meaning it has the same number of rows as columns. Like this is the 2 by 2 identity matrix. It has ones down the diagonal, zeros everywhere else is. And we can show that this is going to result in any matrix multiplying it will result in the matrix being unchanged. Let's take a look at that. I want to multiply this matrix times the identity matrix. So if I multiply this, remember I take this row times the first column, so negative 2 times 1 plus 6 times 0. This row times the second column, negative 2 times 0 plus 6 times 1. The second row times the first column goes here, 3 times 1 plus 5 times 0. And then the second row times the second column goes here, 3 times 0 plus 5 times 1. Notice this results in exactly what we started with, the matrix A. If I multiply in the other direction, I see also, right? We'll just do a couple here. 1, 0 times this first column, 1 times negative 2, 0 times 3, gives me a negative 2 in the first place. It doesn't change the matrix. It's the identity matrix. We can also use our calculator to show it. Here's the calculator commands. But we're really not going to multiply the identity matrix on our calculator because we know it doesn't change the value of the matrix. So our n by n, any dimensions, like a 3 by 3 would have 3 rows, 3 columns, ones down the diagonal, zeros everywhere else. Okay, I want to determine if these two matrices are the inverses of one another. If it's true, then that means that A times B would have to equal our identity, and B times A would equal the identity. So let's check it. Let's calculate A times B. So that would be the matrix 2, 1, 3, 2 times B, which is 2, 1, negative 3, 2. So I'm going to multiply this first row times the first column there. So 2 times 2 plus 1 times negative 3. In my second space, I'm multiplying the first row times the second column. 2 times 1, 1 times 2. And then the second row times the first column, 3 times 2, plus 2 times negative 3. And then the second row times the last column, 3 times 1, plus 2 times 2. Work this out. So right here, I would have 4 minus 3, that's a 1, looking good so far. 6 minus 6, that's a 0. Okay, we're doing great. 2 plus 2, that's a 4. It can't be a 4. It needs to be a 0 there to be the right. 3 plus 4 is 7. This is not a 1 down the diagonal and 0 everywhere else. So nope, those are not inverses of one another because I didn't end up with the identity matrix. I don't even need to bother to check the multiplication the other way because the first one didn't work out. Okay, so how do we find the identity matrix? Well, what we're going to do is we're going to create an augmented matrix. So we're going to start with this matrix here, negative 1, negative 2, and 3, 4. And we're going to add on the identity matrix at the end. Same dimensions. Now through row transformations, we're going to make this side look like the identity, and whatever happens over here is going to end up being our inverse. So the first thing that I can do is multiply negative times row 1 and put it back where row 1 is, and that'll give me a positive 1 here. So that would go to positive 1, positive 2, negative 1, 0, 3, 4, 0, 1. Now I need a 0 here, so I'm going to do negative 3 times row 1 plus row 2 and put it back where row 2 is. So I would have this first row stays the same, but negative 3 added to 3 is a 0. Negative 6 added to 4 is a negative 2. Positive 3 added to 0 is a 3. And 0 added to 1 is 1. Now I need a 1 here. So, well, actually, before I get a 1 here, notice that I can get the 0 here by adding these two together. So let's do that first. We're going to add row 1 plus row 2 and put it back where row 1 is to get a 0 there. So I'll have 0 plus 1 is a 1. Negative 2 plus 2 is a 0. 3 plus negative 1 is a 2. And then 1 plus 0 is a 1. And then here, if I divide negative 1/2 multiplied times row 2, I'll get a 1 here, and that's what I need. So 0, 1, and then that would be a negative 3/2, and that would be a negative 1/2. So our inverse matrix, which is denoted like this for the inverse matrix, is this portion right here. 2, 1, negative 3/2, negative 1/2. Now I can verify this by multiplying this matrix times this matrix and getting the identity and the other way around as well, but we're also able to verify it with our calculator. So let me get back then. I'll just show you with the calculator how to do it. So I can take here and go into the matrix key. Let's edit matrix A to be a 2 by 2, 2 by 2, and we're going to fill in. So we're going to go negative 1, negative 2, 3, 4 is our original matrix here. So let's quit out of there. And then we're going to go back into the matrix, pick up A that we just made, and put the inverse on it. Notice that this is exactly the same as this matrix. And if you can't see that, remember you can hit second. Where's my fraction key? Why am I not seeing where to go for the fraction at the moment? Oh, maybe it's in the math. Yeah, I maybe don't need the second. I go to the math key. Yeah, that's where it is. Option 1 changes everything to a fraction there. So it looks identical. Okay. Now, that's our process for finding the inverse of the matrix. We just make the identity matrix at the end of our augmented matrix, and then do row transformations to switch places so that the identity matrix is over here, then whatever is over here is our inverse matrix. All right, let's find this inverse matrix. So this one is a 3 by 3. So we're going to go negative 2, 1, 0, 1, 0, 1, negative 1, 0, and then put the identity on. 1, 0, 0, 0, 1, 0, 0, 0. Now, to get a positive 1 here, I can just flop these two rows. And I'll have 1, 0, 1, 0, 1, 0. And then I'll have negative 2, 1, 0, 1, 0, 0. And then negative 1, 1, 0, 0, 0. All right, now I can do 2 times row 2 and put it back where row 2 is to get a 0 here. So that would look like row 1 stays the same, 1, 0, 1, 0, 1, 0. 2 added to negative 2 is a 0. 0 added to 1 is a 1. 1, this would be times 2. 2 added to 0 is a 2. 0 added to 1 is a 1. 2 added to 0 is a 2. And then 0 added to 0 is a 0. Now, I can also just add row 1 plus row 3. That was 2 times row 1 plus row 2. I don't mess that up. And put it back where row 3 is. All right, so 1 added to negative 1 is a 0. 0 added to 1 is 1. 1 added to 0 is a 1. 0 added to 0 is 0. 1 added to 0 is 1. 0 added to 1 is 1. Now, I've got 1 here, 0's beneath, we're good. I've got a 0 here, a 1 here, I need a 0 here. So I'm going to do negative row 2 plus row 3 and put it back where row 3 is. So the first two rows stay the same. 1, 0, 1, 0, 1, 0, and 0, 1, 2, 1, 2, 0. All right, now, 0 added to 0 is 0. Negative 1 added to 1 is 0. Negative 2 added to 1 is negative 1. Negative 1 added to 0 is a negative 1. Negative 2 added to 1 is a negative 1. 0 added to 1 is a positive 1. All right, now I need this to be a positive 1. So I'm going to do negative row 3 and put it back where row 3 is. Okay, so that's going to look like our bottom row is now going to come 0, 0, 1, 1, 1, negative 1. All right, now, before I do that, notice I need a 0 here, so I can also add this row 3 with the negative sign on it to that row 1 and put it back where row 1 is. So I'd have 0 plus 1 is 1, 0 plus 0 is 0, negative 1 added to 1 is 0, negative 1 added to 0 is negative 1, negative 1 added to 1 is 0, and 1 added to 0 is 1. I can also multiply this by 2. So I'm going to do 2 times row 3 added to row 2 and put it back where row 2 is. So 0 added to 0 is 0. 0 added to 1 is a 1. Now, negative 2 added to 2 is a 0. Negative 2 added to 1 is a negative 1. Negative 2 added to 2 is a 0. And 2 added to 0 is a 2. All right, notice I've got the identity matrix here now. So this part over here is my inverse. So A inverse would be negative 1, 0, 1, negative 1, 0, 2, 1, 1. And you can plug that into your calculator to verify that that is indeed my inverse. So when do I not have an inverse? If I have a determinant of 0, the matrix does not have an inverse. Okay, it's not invertible. So the fact that I get an inverse tells me my determinant is non-zero. Okay, so how can I use this to solve a system of equations? If I set it up as where I'm looking at the matrix of coefficients of the variables multiplied times the variable matrix equals the constant values, then I'll be able to solve for those variable values by taking the inverse matrix and multiplying it times the coefficients, right? Because these will result in the identity, which just leaves me back to variables. Let's see how this looks. I'm talking about setting up this equation here as being the matrix of the coefficients. So the coefficient of x's are 3, 6, 0. Coefficients of the y's are 6, 4, positive 1. And the coefficients of the z's are 3, negative 2, negative 1. Now, times the matrix of the variables x, y, z equals the matrix of the coefficients 12, negative 4, negative 3. What's on the equal sign? Now we can see by multiplying this row times this column and equaling it to this value, we end up with the first equation. By multiplying the second row times this column and equaling it to this value, we end up with the second equation. And multiplying the third row times this column and equaling it to this value, we end up with the third equation. So what we just saw says our x, y, z is the inverse matrix inverse times this guy. All right, let's figure it out, and we'll use our calculator here. So I'm going to pull up my calculator, and we're going to go into second and matrix, and I'm going to edit matrix A to be a 3 by 3, and my entries are 3, 6, 3, 6, 4, -2, 0, 1, -1. All right, now let's quit out of there. Second matrix, and I can either invert A and write it here and do it by hand, or I can make vector B, oops, I meant to edit, make vector B this matrix here. So I'm gonna, where's my calculator? Go into edit B. I did it again. Edit, there we go, B. And this would be a 3 by 1, so 3 by 1. And our values are 12, -4, and then -3. All right, so now if I go to the home screen, and I go to second matrix, A inverse times second matrix, B, we get our solution set. And again, I can change those to fractions. And we have 1/4, 1/4, 13/4 as solving this system of equations.